For today's lesson, we are simplifying expressions. So an equivalent expression, or let's talk about expressions first. Remember, an expression is a problem that does not have an equal sign. So 2x plus 3 is an expression. Equivalent expressions are algebraic expressions that simplify to the same value for any value substituted for their variables that they contain. So equivalent just means equal. An expression means no equal sign. So two expressions that mean the same thing, but they look a little bit different. So which of the following expressions appear to be equivalent? So if I have a number outside of a parenthesis, I have to distribute that. So I'm going to distribute this 3 and multiply it by everything inside the parenthesis. So 3 times n is going to be 3n. And 3 times negative 4 is going to be negative 12. So this actually simplifies down to 3n minus 12. 3n minus 6, there's nothing to simplify there. 3n plus 4, again, nothing to simplify. 3n minus 12, nothing to simplify. This one has the 3 outside the parenthesis again, so I'm going to have to distribute that 3. 3 times n is 3n, and 3 times negative 2 is going to be a negative 6. And then 4 plus 3n is simplified as well. So if I zoom back out here, it asks which of the following expressions appear to be equivalent. So 3n minus 12, I see this one here, and I also see one down here. And then I see a 3n minus 6 here and 3n minus 6 here. And I also see 3n plus 4 and 4 plus 3n. You can write them in a different order. You just want to make sure that the signs for each term are the same. So the 3n is positive here in the first one, and 3n is positive in the second one, and the 4 is positive in the first one, and 4 is positive in the second one as well. So they would be the same. Like terms are terms with the same variables raised to the same power. So I put examples here under like terms. 2x, 5x, and x are all like terms. 5n squared, negative 6n squared, and n squared are all like terms because they all have the n raised to the second power. Unlike terms would be 4x, 8y, and n. They're all different letters. They're not the same. They can't go together. 8b squared, 7b, and 6b to the third. Well, they all have b's, but they have different exponents, so they can't be like terms either. They can't be combined. So example 1, combine like terms in each expression. So this one, I have 3x plus 2x. Same letter, same exponent of 1, so I can just add the numbers out front, the coefficients. 3 plus 2 is 5, and our variable is x, so that simplifies down to 5x. Next, we have 4x minus x plus 2x. They all have the variable x, so I can combine all of these. I do want you to remember that if you just have a regular x, there's really a 1 in front of that. So you don't have to write it, but just remember that it's there. So we have 4x minus 1x, that would leave us with 3x, and then 3x plus 2x would leave us with an answer of 5x. Oops. And then 13r minus r, again, there's that one variable. So 13r minus 1r would leave us with 12r. Simplifying algebraic expressions. So simplify here means to combine like terms and eliminate grouping symbols. So whenever the directions say to simplify, that's what you need to do. So example 2, simplify each expression, and as I'm looking here, this 4n to the third got pushed down to the next line. It needs to go back over here. Oh, wrong thing. 4n to the third. And then when we go back here, we can cross it off. That's not really part of that problem. So go through the problem. 7x and negative 5x are like terms. So 7 minus 5 is 2. So those would simplify down to 2x. And then I have 18y squared and negative 9y squared. So 18 minus 9 is a positive 9. So we have plus 9y squared. and x and y squared don't go together, so that's our final answer. The next one here, I have 4y to the fourth power minus the quantity of 3y squared plus 3y to the fourth, and then plus y squared. So I see that this negative sign out front is really like a -1 outside of that parenthesis, so it needs to be distributed inside. So you're multiplying both of those terms by a -1. So our new problem, -1 times 3 is going to be a -3y squared, and a 3y to the fourth times a -1 is a -3y to the fourth, and then we have the plus y squared. So now we can go through and simplify that. So my first term, 4y to the fourth, there's another y to the fourth back here, it's -3. So 4 minus 3 is 1y to the fourth, so we just write y to the fourth. Then I have -3y squared, and there's a positive y squared here. So -3 plus 1 would leave us with -2y squareds. And y to the fourth and y to the second is not like terms, so we cannot combine them. That would be our final answer. And our last problem here is 6n to the third plus 3n squared minus 4n to the third. So nothing to simplify before I combine. So 6n to the third would go with -4n to the third. That would be 2n to the third. And then I have this 3n squared by itself. There's nothing else left, so we just bring that down to be part of our answer of plus 3n squared. And we can't simplify any farther there. Now moving on to real-world expressions. Example 3 says to write and simplify an expression to answer each question. So part A, Carlos is buying school supplies. He buys P packages of paper at $3.50 per package and P packages of pens at $2.50 per package. What is the cost for paper and pens? So he's buying P packages of paper, so that would cost $3.50 per package. Plus, he's also buying pens, and he's buying P packages of those as well. So he's buying $2.50 times the number of packages. So that is the cost for his paper and pens, because we don't know how many packages he bought of each. Now for part B, Carlos buys 2 fewer packages of pencils than packages of paper. Pencils cost $1.50 per package. What is the cost for pencils? So we have to do $1.50 times, it tells us that he's buying 2 fewer packages of pencils than he is paper, but we don't know how many packages of paper he bought. We do know it's represented by the letter P, and 2 fewer would be -2. And then we can simplify that. We can multiply that $1.50 by everything inside the parentheses. So $1.50 times P would be 1.50P, and then 1.50 times -2 would be -3. And we can simplify this one up here in part A as well. I missed that. 3.5 plus 2.5 is 6. So that would be 6 times however many packages he buys. And then C, our last question, what is the total cost of paper, pens, and pencils as described in A and B? So what's the total? Well, we're going to have to add our two answers together. So we're going to have 6P plus $1.50P minus 3. So we have to combine like terms. I have 6P minus, plus $1.50P. That would be 750P. And then we have that minus 3 at the end. That can't be combined with the 750 because it does not have the variable P. So this would be his final cost of everything. The other thing I wanted to point out is I wrote $1.50, I wrote 1.50, and 350, 3.50. In your answer, you don't have to have that 0 because it really doesn't mean anything. But if I told you he bought 10 packages, P was 10, then you would have to plug that in. Your answer has to have the correct number of digits in it to be written as money. So you always need to round to the nearest hundredth. So if you got, let's say, 13.5 on your calculator, that's actually $13.50. So you would have to add that zero onto your answer. So that's why I left it in the problem, because hopefully when you have problems like that, you won't forget to write it.